So, hi guys, our topic for this report is about the property of gases, especially air. Property of gas. Gases have three characteristics properties. 1. They are easy to compress. 2. They expand to fill their containers. And 3. They occupy far more than space than liquid or solid from which they form. Compressibility. An internal combustion engine provides a good example of the ease with which gases can be compressed. In a typical four-stroke engine, the piston is first pulled out of the cylinder. The piston is then pushed into the cylinder, compressing the gasoline and air mixture to a fraction of its original volume. Here's the example: intake, compression, power, exhaustion. The operation of four-stroke engine can be divided into four. The ratio of the volume of gas in the cylinder after the first stroke to its volume after the second engine. Modern cars run at compression ratios of about 9:1, which means the gasoline air mixture is compressed. The spark or lug at top of the cylinder fires as the resulting explosion pushes the piston out of the cylinder in the third stroke. Finally, the piston is pushed back into the cylinder in the fourth stroke, clearing out the exhaust gases. Liquids are much harder to compress than gases. They are so hard to compress that the hydraulic brake systems used in most cars operate on the principle that there is essential no change in the volume of the brake fluid when when pressure is applied to this liquid. Most solid are even harder to compress. The exceptions belong to a rare class: compounds that includes natural and synthetic rubbers. Most rubber balls that seems easy to compress, such as racquetball, and filled with air, which is compressed when it's squeezed. Expandability. Anyone who has walked into a kitchen where bread was baking has experienced the fact that gases expand to fill their containers. As the air in the kitchen becomes filled with wonderful odors, unfortunately, the gas, the same thing happens when someone breaks open the rotten egg, and the characteristic odor of hydrogen sulfide rapidly diffuses through the room. Because gases expand to fill their containers, it is safe to assume that volume of gas is equal to the volume of its container. Volume of gases versus a volume of liquids or solid. The difference between the volume of gas and the volume of liquid or solids from which it is formed can be illustrated with the following examples. 1 gram of liquid oxygen at its boiling point, negative 183 degrees Celsius, has a volume of 0.884 milliliter. The same amount of oxygen gas at 0 degrees Celsius and atmospheric pressure, the same amount of carbon dioxide gas has a volume of 556 milliliter, which is more than 850 times as large as general rule. The volume liquid or solid increases by the factor about of 800 when it's form of gas. The consequence of this enormous change in volume is frequently used to do work. the steam engine, which brought about the exhaust. The Industrial Revolution is based on the fact that water boils to form a gas that has much lighter volume. The gas therefore escapes from the container, which it was generated, and escaping steam can be made to do work. The same principle is at work when dynamite is used to blast rock. In 1868, the Swedish chemist Alfred Nobel discovered that highly dangerous liquid explosive known as nitroglycerin glycerin could be abducted onto clay or sawdust to produce a solid that was much more stable than the safer to use. When dynamite is detonated, the nitroglycerin decomposes to a mixture of carbon dioxide, H2O, water, nitrogen, and oxygen gases. Because 29 molecules of gases are produced for every 4 moles of liquid that decompose, and each mole of gas occupies a volume roughly 800 times larger than the mole of liquid. This reaction produces a shock wave that destroys anything in its vicinity. The same phenomenon occurs at much smaller scale when we pop popcorn. When kernels of popcorn are heated in oil, the liquid inside the kernel turns into gases. The pressure that builds up inside the kernel is enormous, and kernel eventually explodes. Pressure versus force. The volume of gas is one of its characteristic properties. Another characteristic properties is the pressure the gas exerts on its surroundings. Many of us got our first exposure to the compression of gas when we rode the neighborhood gas station to check the pressure of our bicycle tires. Depending on the kind of bicycle had, we added air to the tires until the pressure gauge read below 30 to 70 pounds per square inch. Two important properties of pressure can be obtained from this example. The pressure of gas became larger as more gas is added to the container. Second, the pressure is measured in units that describes the force exerted by the gas divided by the area over this force is existed. Okay, that's it.